Hi students, welcome to physics class. Today we are going to discuss about rectangular components of a rectangular components of a vectors in 3 dimension. Now take x-axis, take y-axis, take z-axis. This is center O. Now from x to y-axis, take a resultant vector. This is resultant vector R. Take a resultant vector R. This R makes an angle alpha with x-axis. This resultant makes an angle beta with y-axis. This resultant makes an angle gamma with z-axis. That means this resultant vector makes an angle alpha with x-axis. This resultant vector makes an angle beta with y-axis. This resultant vector makes an angle gamma with z-axis. Here consider this is ax because x. This one is z because it is z. Consider this is y, that means it is ay along y-axis. Ax, ay, az. That means consider a vector a. This is a vector a resolving to 3 rectangular components ax, ay, az. What is this one? This is a vector a. This is a vector A. A is resolved into 3 rectangular components ax, ay, az. Along x-axis, ax is equal to axi cap and ax is equal to a cos alpha. Similarly, ay is equal to ayj. Therefore, ay is equal to a cos beta. Similarly, az vector is equal to az k cap. Az is equal to a cos gamma. This is about the diagram. This is a cube. This is a cube. Now we are going to discuss in deep about the diagram and rectangular components of a vectors in 3 dimension. X dimension, y dimension, z dimension. Now see ax vector is equal to magnitude of ax into unit vector, that is called ax I. Similarly, ay vector is equal to a y j, that is equal to ay j unit vector. Similarly, az vector is equal to az k vector is equal to az k unit vector. And also we know that ax is equal to a cos alpha, ay is equal to a cos beta, az is equal to a cos gamma. Once again, ax is equal to a cos alpha, ay is equal to a cos beta, az is equal to a cos gamma. These are the important points we noted down from the diagram. Now, consider Consider a vector A represented by O or bar, taking O as origin, construct a rectangular parallelopiped with its three edges, along the three rectangular axis x, y, z. Once again, I am repeating the point. Consider a vector A represented by OR, taking O as origin, construct a rectangular parallelopiped with its three edges along the three rectangular axes x, y, z. Now, vector A represent the diagonal of the parallelopipe whose intercepts along x, y, z axis are ax vector, ay vector, az vector, which are which are three rectangular components. Three rectangular components of A vector. Once again I am repeating this point. Vector A, this is second point. Vector A represent the diagonal of the parallelopipe whose intercepts along x, y, z axis are ax, ay, az, which are three rectangular components of vector A. Next, if alpha, beta, gamma are the angles between vector A and x, y, z axis. Once again I am repeating this point. If alpha, beta, gamma are the angles between vector A and x, y, z axis. Now next point. Remember, OP is equal to OS. TR is equal to OQ. OS is equal to PT. RQ is equal to OT. QR is equal to OT. Once again, OP is equal to OS, TR is equal to OQ, OS is equal to PT, RQ is equal to OT. Please remember these points. Now, using triangle, law of vector, now point 1, take this is a Q, this one is R, and this is O. Therefore, OR is equal to OQ plus QR. Once again, OR is equal to OQ vector plus QR vector. And take this is R, consider R vector. Take this one is a TR vector. Take this one is a OT vector. From this one, OR vector is equal to OT vector plus TR vector. Now, OR vector is equal to OT vector plus OQ vector. Consider this is equation number 1. Now, since TR vector is equal to OQ vector, and also take OP vector, take T vector, OT vector, take PT vector. From this one, OT vector is equal to OP vector plus PT vector, and also take OS vector, take OS vector, and also take ST vector, OT vector. From this one, OT vector is equal to OS vector plus ST vector. Therefore, OT vector is equal to OS vector plus OP vector. Consider this is equation number 2. Since ST is equal to OP, since ST is equal to OP, now equation number 2 substitute in 1. Equation 2 in 1. Therefore, OR vector is equal to OS vector plus OP vector plus OQ vector. Consider equation number 3. Now, A vector is equal to AX vector plus AY vector plus AZ vector. Consider equation number 4. Therefore, A vector is equal to AXI plus AYJ plus AZK. Consider equation number 5. These are very important equation. Now, therefore, OR whole square is equal to OP whole square plus OQ whole square plus OS whole square. Once again, OR whole square is equal to OP whole square plus OQ whole square plus OS whole square. Therefore, A square is equal to AX square plus AY square plus AZ square. Consider this is equation number 6. Therefore, A is equal under root A x square plus A y square plus A z square. Once again, A is equal root of ax square plus ay square plus az square. What we take? We take only magnitude. Okay, so here what we did? Equation number 6. Now go for angles. If alpha comma beta comma gamma are the angles which the vector A makes with x comma y comma z axis, then cos alpha is equal ax by a. That implies ax is equal a cos alpha, and also cos beta is equal ay by a. That is equal ay. That implies ay is equal a cos beta. Similarly, cos gamma is equal az whole by a. That implies az is equal a cos gamma. Consider these three are equation number 7. Once again I am repeating. Cos alpha is equal ax by a. That implies ax is equal a cos alpha, and cos beta is equal ay by a. That implies ay is equal a cos beta. Cos gamma is equal az by a. That implies az is equal a cos gamma. Equation number 7. Here cos alpha, cos beta, comma cos alpha, cos beta, cos gamma are called the directions called the direction cosines. The direction cosines of the vector A. Once again, here cos alpha, cos beta, cos gamma are called the direction cosines of the vector A. Putting the value ax comma ay comma az in equation number 6. Once again, putting the value ax comma ay comma az in equation number 6. Therefore, a square is equal a square cos square alpha plus a square cos square beta plus a square cos square gamma. Therefore, a square is equal to, take a square common, therefore cos square alpha plus cos square beta plus cos square gamma. Now a square cancel. Now what we get? We get cos square alpha plus cos square beta plus cos square gamma is equal to 1. It means, what is the meaning for that one? It means the sum of the squares of the direction cosines of a vector is always unity. Once again, I am repeating. It means the sum of the squares of the direction cosines of a vector is always unity. Now go for a numerical so that we can easy to understand. Numerical. If vector A is equal to 2i plus 4j minus 5k, find point number 1, magnitude of A and point B, the direction of cosines of vector A. Once again, I am repeating the question, my dear students. If A is equal to 2i plus 4j minus 5k, find point number 1, magnitude of A, and point number 2, the direction of cosines of vector A. This is the question. Now see, solution. Given given, what the examiner given, vector A is equal 2i plus 4j minus 5k. A is equal to I plus 4j minus 5k. Therefore, magnitude A is equal to root of ax square plus ay square plus az square. Therefore, magnitude of A is equal to root of 4 plus 16 plus minus 5 whole square plus 25. Therefore, magnitude of A is equal to root 45. Okay. Now, we are going to find directions. Cos alpha is equal to ax by a, that is equal to 2 by root 45. Similarly, cos beta is equal to ay by a, that is equal to 4 by root 45. Similarly, cos gamma is equal to a z whole by a, that is equal to minus 5 by root 45. Therefore, cos alpha, cos beta, cos gamma gives the direction of vector A. So this is about the numerical. I hope you understood rectangular components in 3 dimension as well as one numerical. Thank you very much for watching this video. Thank you.